Hello, hello. Hyperland. Issues. Okay, so there is apparently has been this update, I guess, where I'm using only a part of my screen so that this window can leave over there. But if I pin it and I switch workspaces, then it moves, which is very annoying. So what I use is a strut. There is no issue about that. Hyperland. Do they have a change log? Is it called strut? I think it's called strut. Move. I'll close this. Yeah, it's called struts. Wait, maybe it's not called struts. We add reserved. There you go. Reserved. Reserved. It's called strut and nitty. I want reserved and a floating window. Pinned window. Rethonk layouts from the ground up. It's probably this one, right? They have rethonk something. This is a monumental layout that changes fundamentally how we treat layouts. It's still whip with many features missing. Yeah, there is a scrolling layout, the monocle layout. As for box, changes to reserved areas are not updated. If I open a new layer which has a reserved area, the area is only respected after a config reload. And subsequently entering and leaving. Maximize windows. Whatever. Alright, what do we do though? I was also thinking that I can do just change the this thing altogether. If I reserve like this area, for the actual monitor, then you can see the whole monitor. What's on the bottom though is the question then. Let's see, I have a chat. Which chat? Over here. We could put something on the bottom too. Instead of having the window, I can just put some text there, I guess. Text. From a file. Okay. How about we create like this. Probably could be done better. Bum, 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 bum. Any casters? TCAP. Right. I'm currently rethinking my beautiful streaming professional setup. What do you think? If I make the currently doing thing on the bottom, it probably could be done less ugly though. Actually, can I do the browser thing there? From a file. Probably can, right? So that we can do this thing better. Alright, let's call this stream bottom HTML. HTML add body. If I get rid of this, but I instead do the browser. Can you not do this? Oh wait, no, it is present there. Okay, nice. So now then we can just do... Where do you put the style? Over here. Body. Background. Okay. The width. Right, there we go. And now we can just put something here. Color. White. Can I make it so that it refreshes automatically? Refresh browser. I can probably do the as with HTML with JavaScript though. Script. Document. Unload. Set interval. Refresh. Every second. JavaScript. Reload page. Window location reload. Does this work? I think it doesn't. Is it not document unload? It's window unload. Of course, that's the reason. All right. Function delay, right? Oh, there we go. Now it works. Okay. Easy. Oh, this is ugly. How do you make it to be not ugly? Was everything moved to the right now? That also is weird. Alright, I'm going to start working on Kast in a second here. As soon as this is kind of working. Scrolling weirdly. Alright, whatever. Can you do the padding on the body? Maybe not. Loud. Hello, I check. How are you doing? You're streaming like 24/7 or something, are you? You must have done a lot. Unlike me, who is doing everything but actually making progress on the language. Alright. I was just trying to change my thing, you know. Maybe like if I asked AI how to do this, it would be actually faster. But whatever. I just created this HTML, which is now on the bottom. Yeah. I mean, it's not like too bad. Alright, and then I want a second one. How do I make the second one to be on the right? You have like the thing. Hold on. How do you do this in CSS where you align the things horizontally? That's possible, right? Div. We do div. A bunch of divs. I want to have another div. Let's say that this is just going to be the same one. But this one is going to make this to be on the bottom. What I want it to be on the right. Style. Okay, hold on. CSS flex. Is it flex? CSS horizontal divs. Oh no. Want to spend the next few months in hell? Resign and AI your way in. Container inner. Inner child. Float left. What? They must be
go bed. I'm tired.
loud. You're tired. Go to bed. Thanks for the raid. Hold on, let me just learn a little bit of CSS here. It's because Hyperland rethunk the layouts, so it doesn't work, the thing that I was doing previously. You do display flex. Right? Is that all that you do? Centering CSS is pain. I don't want to center them. I want them to be side by side. Actually, this worked. You just do the display flex. That's all. Like, it was a lot more pain previously, but they like added this flex stuff, right? I have never used it because what I've been working on is using like very old stuff. But yeah, it's not that bad, you know. Let me call these two things blocks. And then we just say that blocks have the margins like this, right? Oh wait, yeah, and we also could center them. Yeah, I don't know. I just want to like do this thing. So that what we're currently doing. What I'm currently doing is we are going to work on string interpolation, and then later I'm going to do the other things, right? I don't need the title ID here. I mean, maybe just do the unordered list instead, and this is the list item, right? Yeah, that's better. Wait, how do you make the thing? Like the checkboxes on the list of things? Hello, Amsoft. I mean, let's just do this for now. This is good enough. Alright, whatever. Might work on this later to make it look better. Okay, we're going to work on string interpolation, this thing that I started yesterday. I did not finish it. So we have a lot of changes. The end goal is very professional setup now. Oh, wait, what changed? How did it break? What? It was working, right? Just like a second ago. What? Oh, display. How did this even happen? Did I press the... I guess I pressed the button. Wait, what? Display flex? Lay is flex. Can I do this? Please, thank you. Alright. I press the button. That's classic Vim. You just press a button and then, like, it does the Vim things. Every button does something. All right. Yeah, the goal would be so that, I guess specifically the mathematical operations, what I want is when I'm doing like the addition, over here right now in the JavaScript target, what we're doing, I'm calling into the function called Kast op-add A and B, while in reality, what I want is I just want to have something like this. I just want to, similar to OCaml. Wait, I already have this in OCaml, apparently, right? I had it like hard-coded. I think it was not working, right? But anyway, this over here, I wanted to say like A plus B. There we go. And that's all. So we're generating the JavaScript code, which takes the A, takes the B, and generates code like this. Right. Because by inlining, like, and then we implement the actual inlining of the functions, and this should remove a lot of the overhead that I have, right? Okay. So currently, something doesn't work because I was doing something and I didn't finish it, I guess, right? Parse with Lexer. Can I say just let parse with Lexer be impl parse with Lexer, right? And that should work. This argument will not be used by the function. What do you mean it will not be used by the function? Result. Okay, yes. So result impl result. Type result. Is this thing. Rule set with all new syntax. Parse with Lexer, which means that like I literally am moving everything from the impl to here. Why am I doing that? Why do I even have the module called impl? Why do I even have that? I don't even need that, right? I just move everything from here to here directly. So it's not impl expect eof, it's just expect eof. And it's not impl parse, it's just parse. Alright, so the only error right now, module token is Kast token. We already have that. We already have the Lexer, AST, syntax, open Kast util, open std. Effects are already included. Okay, there we go. So this is the error here, right? So when I'm seeing, this is what? This is when I'm parsing the simple, right? So I see the no, this is the token, which is the interpolated string token, right? So every interpolated part should be... So we have the basically the list of tokens here. In every interpolated part, we need to convert this list of tokens into the AST. Right? So we do AST interpolate, and this is going to be parse with a lexer, and lexer is going to be lexer init with. So I'm going to use the current context rule set, I guess, right? Wait, no, no, rule list here. This is the rule of the lexer. This is not the parser rule set. Lexer default rules, I guess. And then the tokens is tokens. And the URI is going to be context lexer source context lexer URI. So we have the lexer, and then we have the rule set, yes. And the rule set is going to be context rule set. So this is the parser rule set. And this is going to give me the result, right? Inner that result be this. So this result is the parsed result. We have AST, we have rule set, we have trailing comments, and end of file. So I guess I need to make sure that I'm not losing the trailing comments, otherwise the formatter is not going to work. Or we can like ignore that for now. AST trailing comments. Rule set with a new syntax and the file. So this is the position. I guess I can ignore the end of file. Rule set with all new syntax is going to be ignored. Trailing comments, I'm going to keep this warning here, right? And this AST, which is inner AST, is going to be the interpolated AST. Is the idea, right? Kast parser. Wait, what happened? Oh, it's the default syntax. Parser rule set T. Parser rule set T. Okay, success. Okay, here's what we're going to try, right? Echo, print hello username, and then we try to parse this. Is this going to be parsed properly? So we have hello and then username. This is right. Yeah, so we have a function print. Core apply. Why is this a curly bracket here? It's a curly bracket because we have this as a group actually there. That makes sense. It's a little bit annoying to see this in the output, I guess, but okay. It does make sense. So the argument that we are calling is the string where delimiter is the double quote. Hello. Username identifier. Okay. What if I do hello and then we do here a 2 plus 2? Right? Yeah, there we go. So this actually successfully parsed it as a 2 plus 2 inside there. It seems. Okay. Maybe I could like print this interpolated string in a better way. But whatever. This works. And if I have something else after, then this is going to be the thing after the interpolated part. Okay, nice. So now I have parsed it. And by the way, so what we can do is we can use the other string inside, right? Like this. Yeah. Easily. I think one of the things that is actually not going to work is that if I say like 2 plus unit, this is not going to be parsed. Yes. Because I expected end of file. So the reason is because this over here is the closing bracket, and so I'm like doing the tokens until the closing bracket. Right? This is good enough for now, but I think I could like have the token trees, since this is already a tree, right? For the strings, we could do the same for the parentheses. So we could count the parentheses. That's what Rust does, I believe. All right. Anyway, doesn't matter for now. So if this is parsed, what do we have now? Core syntax line 1639. Okay, so this is the quote. When I'm quoting a string, what do we have? We have a quote ASD. We have complex or simple. Simple has the ASD. Yeah. I think what we are going to do here is that if this is the AST string where parts is a single part which has content, so it's not actually having the interpolated part. In this case, it's a simple one, right? Okay, interpolation is to do over here. Okay, that's literally what we have. All right, so this, how should this even work, right? So what do we have interpolated? The way the language works, we are doing the lexing, then we're doing the parsing. During the parsing, we don't differentiate between the different kinds of expressions is the issue, right? So A is just looks like A, right? But if A is like on the left side of an equal, then it's an assignee expression. Otherwise, it can be a type expression, a place expression, a regular expression, or a pattern. So does it mean that when it is inside of the native, does this always have to be an expression? Do I ever want to do something else? Like, for example, I mean, we can start with that, right? Because like this is always an expression. Well, I mean, I guess the native thing itself, if it is an expression, then the interpolated things are expressions, maybe? I'm not sure, actually, if that's the correct thing to do. let's just make everything an expression, I suppose. So this means also that the in the core syntax we have the native expression, right? It must be an expression. So we have an expression native thing. And right now this expression is always a string, right? But what we want to have is we want to have the interpolated string, which means that this is actually going to have the parts, right? I think I will actually have the parts here, which is expression native part list. And expression native part is either raw string or an expression, right? That's what I want. Inference completion. Okay, so here we have instead we have parts. So what we do is we'd say parts iterate function raw underscore string, then we do nothing. But if it is expression E, then complete expression E. Interpreter. So when we evaluate expression native in the interpreter, I think the interpreter should not. I don't know if I would, if I want. I have not wanted this yet in the interpreter. So let's say the parts, right? I'm going to, I guess, say that let native expression be match parts with, if it's a single raw s, then it's going to be s, and otherwise I'm going to fail. Interpolated strings not supported in interpreter natives. And this is the transpiler. And this is the core syntax. Let's do the core syntax first. So when we have the native expression, right? Expression string. So this is... So the way it was working previously is I was evaluating it as a string. But instead of evaluating, I want it to be actually the string AST, I guess. It must be a string AST here, I think. right? So this is my expression, it's AST, and then I say that... What? Let's see here, match expression shape with AST string. So I need to have parts here. If it's anything else, we're going to return init error fancy state kind. And I'm going to just have the parts here, right? I'm not going to need to add any data because I don't evaluate anything anymore. I don't think I have been using the evaluation of the string anyway, yeah. Over here before... returning, we need to say error span native expression must be interpolated string. And now that I have the parts, we're just going to say parts list map. And we have a function. So if we have AST content as, then we're going to have the raw s. And if it is the interpolate AST, then... So in this case, I need to compile this. C compile. I need to compile this as expression, the inner. Right? And we are returning expression inner. S dot raw. We don't capture the span anymore in this case, I suppose. All right, and then in the transpiler, how do I do this in the transpiler? So I need like when we generate the JavaScript AST, this raw thing is just a string, but it should consist of the parts, which might contain another expression inside. Right? Like, how do I do this? Or we can like have raw, and we have like raw list, or I don't know. Let's have its raw list, and then it's going to be of expression list. You know, yeah. Yeah, that works. Then we can combine raw and other expressions. So when I print the raw list, let's just do list iterate function. Well, we just list with print expression. Precedence any. Weiter. What do you mean unbound? What do you mean unbound value precedence? It's literally... Oh, it's because it's underscore here. Makes sense. None. What is this? Optimizer. Row list. Row list. List. Map. Optimize expression. If we have a native expression here. So now this over here, we have parts. This is going to be a row list. And over here, we're going to have the parts list map function. If it's raw, then it's going to be raw as span none. And if it is expression, then it's going to be transpile expression. B. Pure. No. This expression has type no effect expression list, but an expression was of type JST expression list. JST expression. Transpile expression. Pure. No, not pure. Calculate. No, calculate is expression. This one is no effect. Right? Yeah, there it goes. So it's pure indeed. Okay. Is that all? Let's see. Kast. Two plus 2 is still 4. Okay, so this works. Alright, let's take a look at the lots of math. Or should I try the test in the playground, right? Because this one is working with no standard library. So we have the bench, playground test. This doesn't work. One, 6, 4, 2. Fail with lock. This is when I'm quoting. Oh, right. I am actually quoting the thing, right? I'm actually quoting the thing here. Because when I'm implementing the syntax, A more than B as this thing, right? So this is a quote operator, which returns me the AST, which is containing the interpolated string inside, and this is not supported. So in order to support that, I guess I need another thing. This is a special case of an AST, right? So we have another type of quoting the AST, basically, right? We need to quote AST, but it's not going to be a complex. It's going to be a string. It's going to be a string. And this one needs to have the parts inside, right? So since this one has parts, this one is going to have parts, and parts is going to be parts map. If we have the content S, then it's going to be content S. And I need to construct the AST, so I need all of these parts actually to be there. Right, I need a delimiter, open span to parts, and close span. And the quote AST string needs to have delimiter, open span, close span, and the parts are going to be mapped. So we have expression quote AST, and this needs to have a new one, which is a string, expression quote AST string, right? An expression quote AST string is the one with delimiter, open span, close span, and parts, which is a list of expression quote AST string part list, and expression quote AST string part is either content of raw is string, span is span, or it is the interpolate of well, these are just expressions which result in the ASTs in wait, no. Wait, what? Should those expressions result in ASTs? I mean, yeah. So we are interpolating the expression, and this expression results in AST, I think. Oh my god. So when I quote AST, what is this? This is interpreter. This is when I'm constructing the AST, right? So we have a string, delimiter, open span, close span, and parts, right? So in this case, we need to construct the AST where shape is string. We have delimiter, open span, close span, and we have parts which are different, and span, and the data is this. Expression definition site. This is a simple expression. Which means that this should have the definition site, I guess. Is that right? Compiler scope option. So I just do the definition site here, and then we just need to map the parts. So there's going to be parts. If we have the content raw span, then we return content raw span. If we have interpolate expression, then we return interpolate. And this expression must be evaluated to the ASD. And this is my child, right? I think. This is AST content, and this is AST interpolate, which must be the AST here. So this expression must be evaluated to an AST. Evaluate expression hello dynamag h eval value awaiting third. Can I have value expect AST? Yeah, there we go. So if we have not an AST, then, well, I mean, yeah, I want to know what is there. So we just do await inferred, and if we have the value AST, then it's going to be the AST. Otherwise, if it is anything else, then I will just fail. Interpolated as not AST, but this value shape print other, right? Inference completion. If we have this thing, we have string delimiter, open span, close span, definition site, and parts. This is going to be parts iterate. If we have the content, then I don't do anything. If it is interpolate expression, then it is complete expression. Core syntax. Okay, and this is the quote syntax itself. So now when I'm constructing the string, first of all, I need to have the definition site here. And then this content is going to be, yeah, if I have the AST content, raw span, then we can have content raw span. And if I have AST interpolate inner, then we're going to be types interpolate, and this inner must be expression, so we just do C compile expression inner. Is that right? Okay, well, it's compiling. Maybe it works. Who knows? Unexpected token closing bracket. Okay, so here's the code that I've generated. We have A plus B. Okay, this makes sense because this plus should not be in the parentheses, right? Okay, so this is because when I'm generating the JavaScript, I'm putting every expression in parentheses currently. Right, but for the raw list, I need to not do that. So we just always run with parentheses currently. And the raw list has just the list of expressions. But it should be kind of different, right? A little bit. Maybe I just do a function here. Like part, right? And then we like match part shape with if it's a raw, then I'm going to write writer write s, and if it's anything else, then I'm going to print it normally. As a regular expression. Let's try this. Okay. It worked. Is it faster than before? Now let's go to the benchmarking, right? Okay. So, what we can do is instead of doing this, we just do native Kast CMP greater A and B, right? That's what we want. Actually, wait, hold on. Why did this even work? Why did it even work? This should be like the $sign because it's inside of like the inner expression, right? I guess it's because we don't check, like I'm transpiling the ASTs as like the thing and stuff. Was it the correct answer though? Like it was still the correct answer. Am I using the greater? Oh, it's because I'm not using this this operator, I guess. So we can remove this then completely. Boom, 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 boom. All right, so this doesn't matter. This doesn't matter. So let's instead do the benching, the benchmarks. So right now this works in 300 milliseconds, right? This works in 300 milliseconds. So what happens if we just change the equality, right? So here is my runtime, right? And equal. Equal is just a function which returns if this is equal to the other thing. So instead of going through this function, we want to inline it here. And we just say native. So if I say A is triple equal to B, right? Is this still the correct answer? Am I using the equal? I am using the equality. I feel like this is not the correct way to do it, though. Is it not? Oh, this is an wait, what? Yes. No. Yes, this makes sense because this is the expression. It's because I implemented it improperly in the core syntax, in the quoting. Right? When I'm quoting a string, these inner parts, they are just I'm just compiling the inner expression, but that's not the correct thing to do because instead I need to I need to recursively construct the AST, right? Because I'm quoting the interpolated string, right? So yeah, I just need to do construct here instead. Over here we interpolate with construct, quote level, inner, right? And this is not going to work, right? Yes, because we are transpiling the shape value. Why is there a percent? Wait, what? Oh, it's percent x and I. This is the AST, which is x module I, percent I, right? This, we're transpiling this when I'm transpiling this, because this over here is x percent I. So yes, yes. So the problem is that this thing on the left side, the A, is the AST, and we need to unquote the AST like this. There you go. Now it's correct. All right. Does the equality improve the performance? No, this is still 300. If this is all was for nothing, was this all for nothing? Let's see. To do the less, we do the less. To do the plus, we do the plus. To do the plus equal, we do the plus equal. Subtraction is this. A remainder is this. Okay. And like dbg print, for example, is another thing which we can just, instead of relying on the runtime, I guess, right? We can just say, native console log and then escape the x here. So in this case, it's not the AST, but the actual value, so we just do it like that, right? No? Native must be expression, not place expression. Native must be expression, not place expression. That makes sense, but it just means that we are creating the temporary. So if this is a place expression, we need to create the temporary expression. And all of this part can be put over here. No? Because I need the type annotation here. Okay, and this place expression is not here. All right. Wait, so this actually helped, I think. This helped me reduce 30 milliseconds. Right? This helps reduce 30 milliseconds. Is the answer still the same? This still looks like the same answer, right? Okay. This is still not the perfect performance, though. I need better performance. So the next part is... Wait, what's the next part, actually? I don't actually know what the next part is. How to make this faster. So we have the... JavaScript implementation of this. Same code runs in 200 milliseconds. And I'm running in 270. Right? So we want something like this. Instead. So what is happening? Is it because of the break? Let me see. If I do... Like, I am doing a single unwindable block here in the is prime. No, we have two unwindable blocks in the range and in the is prime. So what we're doing is something like this, right? We have the function range, which has a start, end, and this returns the object, which has the iter, which is a function, take is consumer, and then we do let I be start, then we do the infinite loop, then we do I plus equal 1, and then we do if I is less than end. Otherwise, I want to break, right? And this is going to be consumer I. Right? So instead of doing this for, what we're doing is range from 2 to 30,000 dot iter, and we have x into the body of the loop, right? That is the same performance, so it doesn't really matter, right? We have the function is prime. Let me just do the same function here, right? Is prime x. So this is just going to be range from 2 to x. We iterate I into if x percent I is 0. Then I just want to break, right? So in order to break here, we're doing a try, and we're doing a catch. I'm going to throw 3, right? So I'm going to catch E. If E is equal to 3, then return, no, throw token is block token. Block token is some random number. Value is false. If E block E token is equal to the block token, and we return the value. Otherwise, we just throw E. Yo, Zadashaw. Hello, hello. Welcome. Thanks for the raid. How are you doing? I believe you are working on a game, right? Or is that not it? I saw your stream a couple times. I am working on a programming language here of my own, and my language currently is being transpiled to JavaScript. So I'm trying to work on improving the performance of the transpiled JavaScript here. That's in general what I'm trying to do here. The JavaScript is not the final target. Eventually, I will transpile to C, and then eventually I will do the LLVM. But JavaScript is just easier to get started with. And I already made a game with it to test it. Yeah. I have 2 games actually. We have I have made the example game first, which looks like this. Like the dinosaur game, you know? We just jump and collect the stars here. And then also recently I participated in Game Jam. And made this, another just simple game. But a little bit more involved in terms of like animations and things. And so it happens over here, you can see at the bottom, the FPS is 22 here, right? In this game, you like grow the trees and then they explode and then you catch the apples. Basically, that's all. So there's like these animations which take time to calculate because of the inefficient transpiler. So this says 20 FPS in Firefox. If I go to Chrome, it is going to be 150 FPS instead. But yeah, like it's not the problem of Firefox; it's the problem of me transpiling to the bad like the transpilation that needs to be improved. So I can have a high FPS in Firefox too. I'm just cutting a lot of corners. All of the things are async, even those that don't need to be async, and also some other things. Which means probably NeoVim. I do use NeoVim. Look at this over here. This is NeoVim. I don't know. I feel like most of the time though, VS Code works better. I can use NeoVim. Do you guys like NeoVim more? Fine. All right. And what I was working on today is I have implemented the string interpolation. It's not like exactly this string interpolation. I'm doing the interpolation of the generated JavaScript now. So here is how we interface with JavaScript in general. So we have like custom syntax in the language, and everything is done through the custom syntax functionality. Can I set GUI font or something? There we go, look at this. So the A less than B is basically being transpiled into this JavaScript where we put the A expression, and then this is just a raw string of the JavaScript here, right? And previously, instead of that, I was delegating this to a function. So by implementing the string interpolation here, just reducing the amount of indirections, I guess. Right? So this is the code that we're testing currently. It is a very simple code. We're trying to count the sum of all the prime numbers which are less than 30,000. Right? This is the code. That's what it looks like. So everything here is normal, I guess, except for this unwindable block. But unwindable is just the basic like way to implement unwinding in the language, right? So you have like returns from the functions, you can have breaks or continues of the loops, and this is all implemented using this single unwindable functionality. So continues, returns, this is all syntax sugar for using the unwinding in my language, right? So over here, for example, right, we have the for loop for I in 2 to x. this is just syntax sugar, right? If we have for pattern in iterable do body, this has just been rewritten into this, where we have iterable. It must have the iter field, which is a function, which is going to take the consumer. So we rewrite the loop to be calling a function where the body of the loop is converted into a lambda, right? And then the range, which is 2 to x, is just me constructing the object where the iterate is implemented like this. Right? Anyway, feel free to ask questions if you want. But yeah, so this right now, when I'm doing the benchmarks, right? So this works in. Wait, why is it slower now? This is weird, right? Now it says 270. Yeah, okay. So that's what it was previously. Yeah. So this is running for 270 milliseconds, and then we have this thing implemented in raw JavaScript instead, just to compare to the like the maximum performance that we can get out of the JavaScript. And this one works for 200 milliseconds. So I need to figure out how to why do I have 70 milliseconds more. Right, so I'm trying to right now make this JavaScript look more like my generated JavaScript, right? So we don't really have the for loops. We instead are doing this. Range is a function which returns the object with the iterate method, right? And then in order to break out of loops, we're using exceptions for doing we're using exceptions for control flow, because everything is done with like these closures like this, and it's not very much it doesn't have a lot of overhead in JavaScript actually, I believe. But let's see what the issue is here. Kast is looking good. This is JavaScript on the screen. But yeah. Hello. So over here we just return true. What's wrong here? Oh, it's because okay, I'm trying to like write Kast instead of JavaScript here. We're using the round bracket instead of curly brackets for scopes, and curly brackets mean constructing an object instead. So this is still 200 milliseconds, right? This is still very, very fast, even although I'm using exceptions for control flow. Like, they don't really add a lot of overhead, it seems. But let me finish this rewrite. So, like, this over here is also, right, is a loop, but instead I should just call the isPrime function on x, right? There we go. And we do sum plus equal x. Right? No, this actually, yeah, see, now we have 260. Okay, so what's the issue here? Is it actually, wait, maybe it is the try block then. Hello, Raymarch. Is it actually the try then? Maybe it is. So let's comment this and do another isPrime, right? So isPrime is this x into we just do instead for let I equal to I less than x, I plus plus, if x%i is equal to 0, then return false, otherwise return true. This is like the proper JavaScript code, right? So this one, yes, works for 200 milliseconds. But is it because of the try block, or is it because of the fact that I'm constructing the object here? Because I think it maybe is because I'm constructing the objects. So if I instead keep this to be the try block, right? Let's have all of the different versions. Actually, so this is the best version, which you would write if you were writing JavaScript. This is what I am generating basically, and this is the one in the middle, which is going to instead use the for loop, but it's still going to do the exception instead of returning. Okay, you know, it is exceptions, right? Okay. Can I make it so that I don't use the exceptions, though? I mean, sometimes I can do that, but sometimes I cannot. Right? Like, specifically, if I do my loops like the way I'm doing them, then how do I even not use the exceptions? Because if we have like range.iter like this, how do I get out of this? Right? One way we can do it is that the iterate, like instead of doing the exceptions, I guess, we can do the iterate. This just takes the consumer, and this is just going a for loop like this, right? What we could do is that the consumer could return whether we want to continue the loop or not, right? So we say like this, if consumer, or I guess let's say if not consumer, then we also break, for example, right? So the consumer, I'm just going to return true always in this block, and I'm going to do over here return true, and this is returning false, right? But this means that I need to break and then also set the value, right? So like, how do I do that? Well, I mean, let's do this. Let result be true. So over here we'll say result is false and return false. We don't have the try anymore, and we return result, right? And this is 220 milliseconds. So I guess the 20 milliseconds is from the constructing the object to iterate. I don't know, maybe it's like not worth it. If I'm 50% slower than like the JavaScript you would write by hand, is that good enough? Like 50% slower is not that bad, right? You'd want it to be faster than what you would write by hand? Well, I mean, it's because the abstractions in JavaScript are not zero cost, right? So in order for the code to be fast, you want to use something that is like properly optimized. So you don't want to use JavaScript. You want to transpile to C instead, right? But if I, for now, use the JavaScript, then it's fine. I think my plan is to, so we have this plan, right? We have interpreter right now. We have transpiler to JavaScript. Then we are going to transpile to C. I don't think I'm doing QBE. I think I'm doing transpiling to C here. And then eventually we do the LLVM. That's going to be fast, probably, right? Like the problem is like the self-hosting. When do I do the self-hosting? Is Java, and I was thinking that JavaScript should be enough for me to do the self-hosting. the... Oh, by the way, we do have participating in game chats, and we do have a Twitch bot, right? Kind of. I think I need to like just start doing the self-hosting, see if the performance is bad, and if the performance is bad, then decide if I optimize the JavaScript or if I just redo, like if I just do the next, like if I just do the C-transpiler. C-transpiler is not very easy though compared to like JavaScript is so much easier. But the performance, yeah, is an issue. Hello, Nigel. You're first. Congratulations. You are indeed first. I mean, unless somehow I am like let's start with this, right? We have range.iter, right? Can I like have an optimizer somehow? Like, can I somehow convert this to the actual loop without introducing the these loops in the language? Well, isn't this just inlining though? I think this is just inlining, right? So I can calculate. I know like that's if it's that easy, right? To do that though. But if I inline the call to the range, then we see immediately that I'm creating the object with the iter field, and I use this iter field, so I can immediately say that this is this function, and then this function is being immediately called, which means that we can inline it instead. And then once the code is flat, and I'm not using the closures anymore, then instead of using the exceptions, we can actually use the returns. That sounds like a lot of work, though, detecting this stuff. Can I return from outer function in JavaScript? Like, how do they do this? Not directly. When you're inside of the inner function, the return only exits that function, not the outer one. The outer function just keeps living. We can return up the chain. If inner, then return. We can throw an exception. Exceptions seem to have overhead. The engine has to unwind the call stack, create the error object. I don't create the error object. That's not true. De-optimize execution. So we could instead, like, one of the options is that instead of throwing the exceptions, we can do... I'm wondering if this is going to actually work. Instead of throwing the exception, we can model the exceptions using the return values. This probably, like, I would expect this to have more overhead, though. How would I do this? So instead of doing this, the iterate function consumer I. So whenever I call a function, it is going to return something. And if that something is an error, then we need to propagate the error. Just like if it was an exception, right? Is that working better in JavaScript? So I say something like this, you know, let error be consumer.error, I guess, if error is not nil. I mean, if error, we are just going to return error here. How about this? Is this faster? Can I do the dot? Hold on. Can I say like let A be undefined? A error. This is a type error. So how do I do this? So this is the result. I want to say if result and result error. Return result error. Can I say false dot error? So this is undefined, right? It just, you cannot get the fields of the undefined or null dot error, right? Those are the only things. So I'm propagating like this then. Right. So I don't throw, right? But I return from this function the error, which is token is block token, value is false. Right? And this function returns right? So we do if res and res error. Then we do that, we say that E is res error. And then we do this, right? And otherwise we return true. This is 250. Instead of 260 or 70. So it's not much faster, right? What happens if I do error true, token block token, and value is false? So we have a flat object instead of two nested objects. Is that like faster? Because then I just say that E is equal to the result. Like that. That's probably the same, yeah. I don't know. I think we can give up on JavaScript. Like, because the work that is required to translate this to the JavaScript that is fast is a lot of work, and I can just use that time to work on the C transpiler instead. You heard him? Just turn off the internet. Yeah. Well, I mean, I can have the optimizations in the places, right? So instead of writing, here's my test, right? Which is running for 270 milliseconds, right? So my range right now, this code is written in Kast. What we can do is we can instead write this code in JavaScript, right? So we can do something like this. We can do CFG, I guess. Well, I mean, since this is only for JavaScript, it doesn't matter. We just do native, right? We just do native code, which is going to say, you know, for let I be equal to start, I less than end, I plus plus, and over here we just call the consumer consumer I, right? And then we don't need to do the unwind. Like, this gets rid of this unwindable block, which means that we are not using the exceptions here anymore. And this is the inside of the forward, so that we have the consumer here, right? Yeah, I guess I also want the multi-line strings, by the way, right? Over here. Let's see if this works better. Unexpected token 4. Right, because this is an expression. How do I make it an expression? How do I make 4 an expression? Like this. We have none now. Beautiful. Oh, that's right. Yeah, it's because the consumer... because in order to call the function, we need to have the context, right? That's not how we call functions. This is... Yeah, so, like, I need to say context here. Right, there we go. This is the correct answer. Let's benchmark. Is this slower? Is this slower because I'm doing the immediately invoked closure? Really? Is immediately invoked closure overhead? Yes. Because we create a new scope. Well, what I can do... How about I do this? Like, because I need the expression here, I can just say, you know, let's just say cast range from start to end using the consumer, right? So this is an expression. I just need to do something like, you know, I just need to do something like cast range is function start end consumer, and then we just do for I is start I less than end I plus plus fi. Well, this is not an expression. So in order to make this an expression, over here we are making the closure and invoking it, but this is running only once, so it doesn't really matter. And this is not yet because I need to say so I'm going to call this with context, I guess, then. And we have the context here too, which I pass to the function. Is this faster? This is a little bit faster. It's not what I would like to do, though, to have the special implementations of the things. Right? All right, let's instead work on the more important part. Like the way the code is performing right now is only because I made a temporary change. It's because I made a temporary change in my transpiler here, where I don't use the async function. But we're supposed to use async functions, because otherwise we cannot use any async code. If I enable the async code, though, I do not debug in Vim, no. Really. I know that there are the, like, we want to probably look in the dap Vim, right? NeoVim dap, debug adapter protocol. I have never used this thing. I think I will, like, I want to implement the debugging in my language, though, so I will look into that eventually. But I basically never debug, you know, not in VS Code either. I instead use the print debugging, you know, when you just print something to the screen, and that's all. So yeah, anyway, this, if everything is async, is running for 3.6 seconds instead of 270 milliseconds, which means that it's like 15 times slower than it should be. So I think we want to do that. We want to automatically detect if async is needed or not. Let's work on that instead. string interpolation for native expressions. All right, so here's the issue. Because we want to run the code like this example, guess a number game, right? For example, where we are doing the guessing number game, the number has been picked. I need to guess 5, and then it says that I guessed because I'm very good at guessing. But yes, greater, less, right? So it's 6. So in order for this game to run, because interacting with the user is async operation, this needs to have asyncness, right? Here is the prompt, I guess input, right? So we do the read line interface, which is async. So this over here must be async, right? And because of that, because I need some async, I'm just currently compiling everything to be async, even though not everything has to be async, right? So the question is, how do we convert some functions into not being async? The answer is that we want to infer this information that so here's my function type, right? So right now for every function, all we know is what are the arguments of the function and what is the result of the function, but we want in addition to know if the function is async or not. And also sometimes the code should be async. I don't want to do it exactly like in JavaScript or existing languages. We want to be polymorphic over it, right? So for example, consider the map function, right? So what's the type of the map? We have, let's say that we have the list, which is so we have a list of t's, right? Something like this. We are generic over t. We have a list of t's, and then we have the function, which is t into u. So we have t and u as the generic arguments, and this should return the list of u's, right? So this is the type of the map function. But what if this function is async? Then the map function should also be async. It's either that, or we have two separate functions. Map async, this would be like the async function, I guess, and then this means that it's async, which means that we need to write two implementations. So instead of having the two implementations, this is sync and this is async, right? Instead, we want to just have a single map, which is which we add another generic argument, async, right? So this function is, we need to somehow specify this on the type of the function, where this is like async is equal to async or something. I don't know what the syntax should be. And so this is also going to be async is equal to async, I guess. Well, I guess, yeah, the generic argument is like that, probably. I can do this syntax for now. So like, I want eventually to have the proper effect system, but I have not figured out yet what is the path that I want to take. So let's do the temporary only async detection. And then we want to be polymorphic over this. So this is just a boolean, right? This is a boolean, and these two are types. Right? And then what if we have something else? What if we have like call both? Call both is the function that would be calling both function f, you know, and function g, right? What we want is like, what is this function async? And is this function async? This is, so if we want to be polymorphic over there, so we have our polymorphic order, the asynchronous of f and g, and the and then the asynchronous of the function itself is going to be basically equal to f or g, right? So if any of the functions is async, then the asynchronous of the combined is the or, right? I think I can support that relatively easily. Async, polymorphism, and inference. Let's do that. So we want to have the asynchronous, right? So is this async or not? What are we actually storing here? It's not just a boolean. It is not just a boolean, right? Because as you can see in that example which I closed, the async is the expression of type A or B, for example. So this is a value of type boolean. This is a value of type boolean. Let's see, I have this thing called is mutable, and this is the inference variable which is inferring to the boolean, which does not include the ors. Like, one of the things that I can do here is I can do value, but then like it is not guaranteed to be the boolean, but maybe this is fine. Let's do value here. It's just supposed to be a boolean. How about this? How about we say boolean value, and then we say something like boolean value is just equal to value is value, right? Just so that it's a separate type. So when I print the function type, I want to have the async, and over here we will say something like async is equal to print value async value. The var scope of type function async, so it's deepest of this and a end of value async. Unite type function. So this is where we know that yes. So we have the async. So async is going to be equal to value is, we need to unite value a async value and b async value. There we go. So if I know, yeah, this is just the inference unification. Completion. If I complete the async, then I need to complete value async value. Substitute bindings 472 async. Async is value is async value sub value state. Okay. Interpreter core. Evaluate type. Okay, so now we should have like the type expression also. Type expression function should have the async, which is going to be a regular expression. Right? This doesn't even work, and it's like to make this in the parentheses, right? So have a function x and print x, right? Then I do print x, and it should also have fmt, right? So I print x, options, fmtx. Is that right? This doesn't work because these are different types. How do I make it the same type, right? This should be what? It should actually be, oh my god. No. This should be compiled, of type compiled. Right? So yes, I don't do this. I instead say compiled type expression arg. Right? Is that right? And over here we have compiled type expression result. Over here we have compiled expression async value. Well, I mean just async in this case. So now over here I need to just match. Do I have a print compiled? Do I just have print compiled? Oh yes, that's actually yeah. That's what I want. Print compiled options. Let's do this. And print compiled is options for matter. A compiled unit is going to be function options fmt compiled into. So there's going to be what? Compiled kind expression, right? So this is going to be match kind with. If it's type expression, then we print type expression options e. If it is expression, print expression options e. Pattern. Print pattern options e signy place expression. This should work, right? It doesn't. The expression, yeah, because I need to do the print expression options fmte, right? Okay, so now in the interpreter, when we evaluate the type expression, we have the async here, and so we create the type function where async is value is async, I suppose. Let's just have async here. No, let's say fine. Async is value is async. So async is just evaluate the async expression. It's supposed to evaluate a boolean. Complete type expression async. Complete expression async. Native function. When I have a native function, some of them should be async. Native function name, impl. Or I can just say that async, like, because the type is not inferred here, right? Yeah. Async is just value is value, new not inferred. How about this? Bool value, new not inferred. Scope, span. Right, how about this? I'm going to say over here, module bool value. New not inferred. Scope span is value is value new not inferred of type scope span boolean type. So bool type is type inferred span t boolean. Is that right? Okay, so over here, for example, we have the function parse. Function parse is not async, right? So say async is value inferred span. Do I have span here? I think I have span here. So I have value boolean false like this. This doesn't work, right? It also must be like value. Or how about we do this? True bool value inferred span, right? What happens here? LSPO camel format ignoring the mod string syntax error. Why is this a syntax error? That's not a syntax error. Don't lie to me, camel. Is it? How is it a syntax error? Why is the... Oh, this one is unmatched. Wait, why is it unmatched though? What? Wait, I cannot have the right pipe here? Why not? This makes no sense. Why is this a syntax error? Well, if I say this and then true... Why is this a syntax error? I don't get it. Oh, this is a pattern. Forget about it. Forget about it. I don't need this. We just do underscore here. I understand now. This is generic types. Generic types are not async. Async is bool value inferred span false. Let's create this. So this is going to be type T, value is value inferred, span boolean value. Okay, this is when I have instantiation of a generic. No, when I'm applying, when I'm calling a function f, it means that function f is a function, right? Because we all can only call functions. Now the issue is this function async? Right? That's the question. Async is going to be async. So let's do this. Async is a bool value new not inferred scope span. Right? So we allow this function, when I'm calling a function, I allow it to be async or not async. Now, if this is async, then the whole expression is async, which means that we also need to... Okay. We'll add that later. So I need to, for every expression, know if it contains async code inside or not. Right? When I have a type expression, result async. What is this? Let underscore bool value. No, it's not bool value. Its expression is async. What is this? Oh, it's because... Oh, okay, no. This is me initializing the expression, right? So because the type expression for the function... because these are the type expressions, we don't need to do any inference here. But the async expression... Async data signature type expect inferred as type. So we need to infer this as a boolean. What is the type tie? I'm just going to say type boolean is type inferred span tbool. All right. For syntax. When I have, so now we have the function type syntax, right? Syntax default rules. Let's see. So I need to be able to specify this in the syntax, right? So I think the way it should work is that we have the function type, and the function type should have so I should have another optional group here before the argument, I guess, right? Which is going to have async. Async args. Let's call this async args group. Because inside of this group, also the actual... we can do the equal sign. Right? I can do the equal sign. And after the equal sign, we have the value, the async value, right? Is that what I want to do? So the core syntax, I'm going to... what did I call it? That group is called context args, by the way. Not context. Fine, let's call this async. Async is children get named opt async. So async is either an expression. I mean, it is also always going to be an expression, which is potentially a constant. By default, it's going to be false, I guess. And if we don't say async equal something, then it's just going to be true, right? Yeah. Let's see. I'm going to match this. If it's none, then so this must be what? An expression, right? So this is going to be expression constant. Value is value inferred span boolean false. And expression span C state. Unbound constructor e constant. Wait, do I not have the e constant? I do have e constant. It has ID also. So still unbound. Is it because the camel is being stupid though? There we go, now it's bound. Okay, good. So we have this. If it is sum, so this is async group, right? And then we say that also that the async group is the child expect group. Now I want to say async group children is the there's flattened children. If we have the child tuple, yeah. So this is async. Let's just do this here. Ast. No. Group is this and children. So this is the AST tuple. right? So then now I say that if async group, no, I'm going to now match async group tuple gets named opt value. So if it is some value of the async, then we are going to have the I'm going to compile the value into an expression, right? But if it's none, then we're going to have another constant, which is, instead of being false, it's going to be true. This expression should not be constructed. The expected type is state t. What do you mean? What do you mean state t? Oh, because this is not a named argument? Got it. So now we have the async as an expression. This expression, yeah, and then we just do this thing here, and this is async. And this is the actual function itself. Now, we need to do the same, basically, for the function definition, not for the type. Right? So, function, it should also have the async group. Like this. And to copy paste the asyncness. How about this? How about this? Let function async children is this. It's not just children, right? I need to have module C and span. This is going to be async is function async span module C children. Async is function async span module C children. And the type of the function async is just async. Wait, no, this is the type of the function. Wait, why is it not inferred? Why am I creating the not inferred here? If it's an expression. This should be the value, which means that I should evaluate that expression here, right? What's the fastest and best and coolest way to write a parser in Rust? What are you trying to parse, Raymarch? I don't know. You need to parse a cursed thing? There's a bunch of libraries. I never used any. But I'm wondering if you can just use the Kast parser from the... Oh, it's just XML? Okay. What's the coolest Rust XML library? Never used XML in Rust. Wait, why are you writing Rust? Are you writing Rust for work? Are you trying to force Rust on your coworkers? To sneak Rust in the code base? They will have to accept it being in Rust. You will tell them after you wrote it. Makes sense. Compiler eval. Type is Boolean. No, this is evaluating the AST. Hold on, what am I trying to do here? Why is the type not inferred? Yes, a result type expression if this exists. And that makes sense, yes. Okay, I think asynchronous here, I just need to evaluate. I guess we just do something like this. Cast interpreter. Evaluate. State interpreter. Async. Right? I just need to make sure that this is Boolean, which means that maybe in function async I'm going to actually say that this expression expression data signature type expect inference type expect inferred as type inferred t spam t boolean. This is ugly, but okay. Do 1509. What is this? This is when I'm implementing the syntax. When I'm implementing the syntax, which means that it's a macro basically. Can a macro be async? Can a macro be async? Let's do true. Well, I mean, just not inferred actually. What would an async macro even do? Like, I mean, imagine if you are writing like SQLX in Rust, right? Where you have a macro which is connecting to the database at compile time and checking it, right? That means that you need to connect to the database. That would make it async, right? Because that's like potentially the async operation. I mean, the question is like, do I want to treat the database connection as async code or a sync code? But I think it should be async, right? Like especially if I want to be able to target JavaScript, and JavaScript, that would be async for sure. Can I async macro compile itself? What do you mean? Macros don't compile themselves. Hello, Vest, by the way. LSP common. Alright, in the LSP, this is inner compile with handler, right? So we have the result and we have the async. Async is expression, so I need to handle the expression async. Here. It's compiled, and it should work, just like before. So what we should be able to do now... What I should be able to do now is... is something like this. So we have function f, which is, you know, print hello world. And we call function f, right? So now we should be able to just write async here, and this should be parsed properly. Apply must be expression. What? Is it not parsed? Hold on. I think it's not parsed. Kast parse this file. Right? Yeah, we have async is the identifier. So I'm calling the function async here, apparently. Did I not do the async? Did I specify this incorrectly? I have an optional group which says async before the argument. I think this should work. I'm torturing myself with cursed auto tiling in 3D. And there are 53 tiles. We're optimizing Kast.js. Yeah. So far, if I make the async, I think I'm going to run 50% slower than the JavaScript that you would write by hand, which is good enough, I think, for now. And then optimizing it further would probably not be worth it. And instead, we change to this C transpiler. You did your master's thesis on auto-tiling 3D stuff? Show some screenshots? Yes, where's the screenshots? Show us. This definition of the syntax, is this not correct? So this over here means that it's a named group. Inside of the parentheses, we have the named group. The question mark means that this group is optional. right? And we have the async as keyword here, which means that it is a keyword. So why is it used as the identifier? That makes no sense. It's like this file is not saved or something. Maybe I did not... Wait, maybe I did not save it? Maybe I actually did not save it. No, I saved it, right? Async is identifier. Why is this identifier? Good morning, Athano. Let's do instead this. Let's do simpler stuff. Cast parse. Let's do echo async async A into B, right? Like this should be parsed. Right? But it says expected end of file. Got identifier A. Because async was parsed as the identifier. If I do the lexing here, right? It just says that... Well, I mean, lexing doesn't matter much. You basically milked your platformer game project for uni points back in the day. You did research topics related to that. Makes sense. Makes sense. Is your game like out there? Because I've seen the videos of your game, but I have not seen the game itself. Is it somewhere where we can get it? That's what you did with your ECS? Oh wait, did you? You have a very specific setup for it? Let's see. It looks a little cursed indeed. Is this like the tile which is a hill or something? This is weird. Is this a glitch over here, or is that intentional? What are you trying to do with Minecraft? Are you implementing your own Minecraft? Or wait, is this for like this game that you made for the game jam? It was not green there though. Why is it not being parsed? Am I stupid? Let's do this. Syntax, blah, 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 blah. How about I do this? Syntax, async, async, x. Right? So if I do async A, this is supposed to be parsed as this blah blah blah, where x is equal to A, right? Yes. So this file is used. Something is wrong here. Let's copy paste this. Let's do function 2. Let's make this not optional group, but like actual, like with this one. Let's see what's going to happen. Well, this is duplicate syntax, right? Yeah, there we go. So like we have syntax. If we have async followed by something, followed by the arrow, followed by something. Which is core function and core function 2, right? Like, I mean, yes. So like this syntax should be parsed. Why is it not parsed? It thinks that it's not a keyword, maybe? Oh, maybe. Okay, hold on. Let's see how I figure out the keywords. There are continuation keywords, and then there are just keywords, right? In the rule set, right? How do I set the keywords? Add sequence. So we have the keywords of the rule, and we are filtering. Yes, there we go. So the keywords of the rule, I'm only getting the top level keywords, not the keywords from the optional groups. So yes. So I need to do flat map. This is going to be then sequence singleton, and this is going to be the sequence empty. So we have keyword, we have value, right? And then we have a white space or group. Value or white space is whatever. But if we have a group G, then we have like keyword like of parts G parts, I guess. So we say over here that let rec of parts is to seek parts, like that. And this in of parts rule parts, right? And this should work and do it recursively. Okay, there we go. So now we have the function where async is, and what is that? Oh, this is just like a group, right? With nothing inside. That makes sense. But we can also say that async is true, for example, right? Right? So async value is true, or we can say async is like, you know, A or B. And all of this is going to be parsed. Okay, nice. Now what? Now we have the hello world over here. So this is async function, right? Okay. And now when I'm transpiling, I need to know if the function is async, then I am transpiling to async function. Otherwise, I'm transpiling to a normal function, right? But also, how do we know if the function is async? Because I want this to be also inferred, right? Well, now I need to like, I feel like by default it should be inferred, right? If I don't have the async keyword. And like maybe like no async keyword, or I mean I can just say async is false, I guess, but like if I want to opt out, otherwise it should be automatically inferred, right? Function async. Like, so if the if the async keyword is not present, should probably do the not inferred here. Hello, Giancaletito. Wait, what's the scope? Var scope C state. So the next step, now that we can specify the asynchronous of functions, we need to do the inference of all of the expressions. So for all of the thing, we have that, right? The signature, that's what we want. So we have for every expression we know its type, but now we also should know for every expression does it contain async stuff or not, right? So there's going to be a bool value. When I initialize the type expression, what is this? Result expression type signature. So like the result of the type expression is a type, of course. Whether this type expression is async. We don't know though. Or maybe we just do always true. What am I doing on top of Kuverman's head? So used to be on the left. The Hyperland update made it so that like the floating window is like being moved when I'm switching workspaces for some reason, when I'm using the reserved spaces. So I changed my layout of the stream a little bit. New not inferred. Pen. Scope. What's the scope in this case? State var scope C state. I just have state. All right, when I'm initializing the pattern, can a pattern be async? Probably not. So we are going to say async is bool value inferred span false. Patterns are not async, right? Probably doesn't make sense to have async patterns. If I have Asynchronous here can be ignored though. Init assignee. Can assignee be async? I think not. How about we say that async is bool value inferred span of false. So this is the interesting part, right? When I have the expression, these are all of the different expressions. So when I have a reference to a place expression, then the asyncness of this expression is equal to the asyncness of the place expression here, right? Yes. If I have a list of expressions to do, async, let's do this. Async is bool value new not inferred scope span. Right? But we are going to do this. We are going to do this. If any of the expressions in the list is async, then is async, right? So we're going to do list iterate. So we have expressions, right? So we do here expression signature async. Almost like want to say like something like this. Let's have a helper bool value. Let's say implies, like this thing implies the asyncness of the whole thing, right? So we will have something like this. Implies that. This implies that, right? So this is going to be like what? Inference for like once inferred. So I need to do like this value var once it's inferred. We have a function, and if it is a boolean true, then we are saying that that is also true, right? In any other case, we don't do anything. And to say that inference or infer as I cannot do it here though. cannot do it here. I need to do it in the inference impl, I guess. How about I say this? Bool implies I mean, I can just say the unite value here, I guess. Unite value. I just need the span, I guess, right? So we need to have span, unite value, span, this value and that value, right? If one is boolean, then they are all then they're equal. So I just unite them. What if you added a comment? What this does? What do you mean? Over here? This equals true. Means that is equal this. Which means that is equal true. Right? I mean, like, that's what bool implies. Like, I mean, it's kind of obvious because of the name, no? Maybe not. Fine, I add a comment to the code. So I need to do the same thing in all of the other things. If I have the statement though, it's just async, and this is just async. If we have a scope, then that's that. If we have the function, so creating a function is not async. Creating a generic is not async. Instantiating the generic. Did anyone ever use your comment redeem to add an actual document? No, I don't think so. Pew, 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 pew. Can instantiation, like, generics are just functions, so like technically there is potential for it to be async here. Well, I mean, generic itself is an expression, and argument is an expression, right? So, first of all, if any of those are, right? Async is generic, async, and async is arg, async. Let's do this. Right, async is bool value, new, not inferred, scope span, and then we say that generic async implies wait. I can have this there, right? Value implies async. And arg async implies async too. Bool value. Let's see. Implies is inference impl boolean implies, right? Which means that I could have done this here actually. But it's okay. Or is it? There we go. All right, now the generic itself, the type of the generic. We know that the type of the generic is generic. Oh, but generics, they're actually different. The generics are different. I guess we can treat them as not async for now. It's okay. But instantiation of generic can be async potentially. Maybe. Who knows? Tuple. That's okay. Variant. A variant is only async is if the associated value is async, right? So async is value map expression data signature async unwrap or bool value in third false. So it's not async if we don't have the associated data expression there anyway. All right, next, when I'm applying a function, we need to say that the function expression async implies asynchronous. All right, the argument expression could be async. But also, right, so it's not only the expression that evaluates to the function and the expression that evaluates to the argument is async, but also if the function itself is async that we're calling, then the expression of calling a function is also async, right? So yeah, I say over here that the type of the function is inferred as async. Right? Let's do this instead. Let's say function type is async, right? Is boolean value new not inferred scope span. But we are going to, so this over here is async is equal to f type async, right? But also the f type async implies the async So you have 5 million channel points to do a change of plans. Only 4,950,000 left to go. Let's go. You're almost there. What would change of plans mean? I don't know, like, it would change the plans? I don't know. It's not my job to figure out what it means, but the one who has the 5 million channel points. How do I know if a native expression is async or not? I mean, this is just going to be not inferred. We must rely on the inference. On the type annotations in this case. Module definition. Okay. HTML stream status. Yeah. It's ugly, right? All right, we have an if. We have an if. Async. Bool value. Do not inferred. Scope span. I mean, this is pretty straightforward, right? We just create the async, which is not inferred. Then we take all of the expressions, like the condition. If the condition is async, then we are async. Yeah. So condition async implies. Why did I call it impulse? It's supposed to be implies. Async is then async. Async is else async. Then async implies async. Else async implies async. Da-da-da-da-dum. The patterns are never async, so we don't care about that. Async in Kast. Yes. I'm just inferring the asyncness. That's the idea here. Right? And the way it works is that, like, it is going to be, like, we only set the async, like, async, if we know that something is async, then it's going to pollute everything, and it's going to make everything that is depending on this thing async. And for all the other things, we will, like, basically say that it's still not inferred if it's async or not. And I guess it's the job of the completion then, right? If it is not inferred when I want to complete, which I am not, like, invoking the completion yet, that would set it to be not async. But basically the transpiler is going to say that if we know that this is async for sure, then this is going to transpile to async code. Otherwise, it's going to be not async code, I think, for now. Right? Because, like, the way... Yeah, it's like the polluting thing here, you know? Async is just poisoning everything. Quote AST. I'm too lazy to do this right now, so I'll say async is new not inferred scope span. We're going to say to do async may be in children here. I don't think it matters for me right now. We have a loop with a body, then this is async only if the body is async. So we just make them equal. If we have the error, async is inferred false, I suppose. Unwindable. Token is a pattern. So we just have the body, which is async. So let's do that. Target dependent. This is over here the weird part, right? If I have conditional compilation where some so the code may be async or not depending if on the compilation target, but the way I am doing the compilation is I need to infer the whole thing instead. Currently, this is I don't know. Same with the types, right? All of the types must be the same, independent on the condition branch. It's okay here. So the asynchronous must be the same for all the targets. I think it's fine for now. This signature does not matter here. But body async implies asynchronous. If I'm doing the injection of the context, this is expression inject context, which is context type and value. I'm just going to say that async is valued signature async. Current context, this is just the type. Async is false. Implement the cast. Well, I mean, casting is not supposed to be implemented at runtime. I guess let's do that. When we perform the casting, this is expression, this is value. Async is a value. Signature async. Unwind token value. Async. Oh, that's all. I'm done with the expressions. There's more things to do. Let's see. Line 112. This is the tuple, right? So when we have a tuple pattern, tuple expression, tuple assignees, there's a bunch of things here. So this would be async if any of the fields are async, right? So we're just going to say that async is not inferred scope span, and we're going to imply this is tuple of things, right? Yeah, we have the parts, right? We have the parts. So it's somewhere over here. If I have the parts, so this is the part, right? Right. So I can do something like this. Part. I think I want to do this in the other. I mean, I guess we just do this, you know? We just do it separately here. Where's my async? Like, literally, I will do it over here. I will just do parts. Iterate. Part. So I want to say data. Get data. Get data. Kind. Part. No, this is tuple part of. So this needs to be a function, because we have either a field we have tuple of, which has the parts, which is tuple part of, which is either a field, which has a label and field. Okay. Let's have function part, and then we are going to say let expression be match part with field. So we have label, label span, and the field itself, I guess. Then it is the field. And if it is unpack, then it is just that. Then we get data of E. So then we just say that data signature async implies async. There we go. Line 1 to 3. And this is the tuple signature again, right? So in this case, the asyncness we can already ignore because I did this like separately. Line 2 to 8. Pure type. So the pure... Wait, where is it this even being used? Pure. Pure is the one where the async is false. But I need to give it the span still. Unless I give it the span, which is span of camel. Is it position? Line 244. Initialize place expression. Yes, place expression is the same. So if we are dereferencing a reference, then asynchronous is the asynchronous of the reference. If I am getting a field of an object, then because object is an expression, then asynchronous is just get gotten from there. Right? Because field is... Well, I mean, field is a field expression, actually. I have a thing called field expression, which is either index, name, or expression. async is bool new not inferred scope span. So async over here is object async. Object async implies async. But also I need to like match field, and if it is so if it is index or name, then we don't do anything. But if it is expression E, then we do expression data signature async implies async. Three, four, two. If we have a then list, this just misses this span argument. 764 type expression wait, what is this? This is initialized type expression. Result is this data signature async. Right, async is this. So over here we have async is expression async expression async implies async. Okay, LSP hover. Should I be able to hover on the expression and we should know if the expression is async or not? Because we have this in the signature now. So I can say that if this is async, right? So we can say this is the type. Then we'll also say that it's equal if it is evaluated. If something was evaluated at compile time, we show this. But let's also say that it is async, right? Async is this. So I need to print and to print value. Async value. It's compiled. Okay. It is compiled. How do you restart the... Like, the only reason why I'm not using the new Vim is because if I do the LSP restart... Let's go to the test KS. In the playground, right? Like this one. I need to restart my LSP right now. LSP restart. But it's initializing the JavaScript TypeScript language features. Oh, wait, no, it works. Wait, what? Okay, there we go. So it says that this is a function f. So this is a function from unit to unit, and we don't know if it's async or not, right? And then it says async is false because this is a pattern, which is pattern is not async, right? So, but over here, for example, we are calling the function f. Right, let's make sure that this returns, I don't know, int 32. So this will return like 1, 2, 3 here, and in this case, I think it's just really slow right now. No? No auto command save. LSP restart. Right, so this is int32 and async is underscore. All right. So we don't know if it is async until we do this, right? But if I say over here async, oh my god, I cannot save anything here. If I say that this is async explicitly here, then we should be able to see hello. It broke. If I compile here, we do show the types, right? Yeah, there we go. Async is true here. You know what? Actually, here's what I want. How about this? We say const g is a function which just calls function f inside, right? So because I'm calling function f, we should know that function g is async. Why is it not printing anything? Oh, it's because it's constants. I only have constants. I don't have anything. Right? I can call function g here, basically. And then compile this. So we're calling function g, which is async is underscore. It's not inferred. And the reason it's not inferred, I think, is because we are not doing it in the... So when I'm creating a function... When I'm creating a function over here, right? I'm compiling the function. I have compiled the function body. So now, because the function body has the signature, and we know that the function body is async, if the function body is async, then the function itself is async. Then the type of the function is async. That's what we want to do here, right? So we want to do like... yeah, we are like saying that the result type is that stuff, and then async, right? Async. Async is an expression, though. Wait. Async is an expression which I need to evaluate, right? So we know body has signature and it has async, and this should imply that I am async here, right? But async is expression over here. But it's used over here because I'm evaluating it over here. Yeah, see? Yes, this over here is async. Right? So async bool value is the evaluated expression here. In this case. Oh, there we go. So now the function that is async. The function is async now. Okay, because I called the async function, right? Okay. Maybe I did everything that I need to do, unless there is like some simple stuff that is missing. So because of that, what we can do in the transpiler, so now we have async functions. How about this? Let's do type async mode. Let's do this. It's either never or always or based on inference. How about this? So I want it to be based on inference. 233, right? So over here, I have a function. So we have a maybe compiled function. We know that it's compiled now. Maybe compiled function. It doesn't have like the type though, right? Is the issue. Like I have the type annotation in the function signature and then maybe not in the body sometimes if it's implemented through the native stuff. So right? Like what's my maybe compiled function here? It has compiled function, and compiled function has arguments and body, right? But it doesn't have the type of the function. So the body has the signature, which is async, but well, I mean, I guess what I can do is I can do it the other way too, right? So over here, the body signature, like they should be the same. They should imply each other, right? I think they should not be equal, but basically async also implies the body data signature async. They are not exactly. That's like kind of wrong, because the way I mean it's because of the way I have set up the thing. Can I make them just be equal? Like I mark something as async, but the body of the function doesn't actually contain anything async. I will have the compilation error. Let's see if that's going to happen or not. So sure, let's try to do that. So async is body data signature async, right? Well, I mean, it should be something like this. It should be like this. We're going to match async functions with, if it is always, then it is true, right? If it is never, then it is false. But if it is based on inference, then it is body data signature async. Now this over here is a boolean value, so I need to bool value await inferred, right? Well, it should not be await inferred. It should be like inferred opt option. So if it's not inferred, we're going to assume the not async. Default is false. So if it's for some reason the value is not a boolean, we're going to treat it as a not inferred thing. It's okay. And yeah, so async is just async now. And when I'm calling a function, right? So now when I'm calling a function, this is going to be async. Well, I mean, do I need to await? That's the question, right? Async here in the call means that do I need to await? I can also say that, like, let's do true here for now, because if we await something that is not async in JavaScript, it's fine. Do we have overhead actually? I don't know. If I await not async calls in JavaScript, does it have performance overhead? Yes. It's not enough to matter unless you're doing something wildly questionable. So it calls it normally, that takes the return value, wraps it in a resolved promise, awaits it, which yields back to the event loop for a microtask tick. So we are having the microtask tick. So maybe we should figure it out, right? Like, so this is going to be async if function. I mean, let's do async. In the call. So it's going to be async based on the function, not based on the other things, right? All right, let's try. Let's try to just run the cast. Like, the problem with JavaScript is when we call a function and it's not async and you forget to await it, like, it's just going to be like weird bugs, I guess. Right? Examples, guess a number. Right? Like over here, right? Because I'm not awaiting the number. I guessed here. I did not guess though. Let's go to guess a number game, right? And if I do over here that this is my guess, let's do dbg print guess. Let's do it like this, right? So yeah, my guess is none. It's not a number because the prompt just returned a promise and I tried to parse it as a float, right? So what we need to do is we need to do in the standard library. We need to properly annotate the things which are async. stdioks, right? So the input, this one is async. So let's see if just annotating this is enough. It is not enough. Well, you look at this. Async is true. Main is async. Is true. Async is true. Async is true. This is unknown to be async when I'm printing you guessed. This function, which is prompt, is async. True. Yeah. I don't know. Like, and the function, the main function, is inferred to be async properly. I mean, let's take a look at the generated code then, I suppose. Can I collapse everything here? Any targets compiled? Alright, this is a little bit of the output of our transpiler. Right. Main. Wait, hold on a second. Main is a function that returns promise. Look at this. Main is a function that is async correctly, right? But when I'm calling the function, it's not async. Why not? Also, when I'm calling the function, I guess, let's see, like, where is this being used? Guess again. It's been used over here, right? So this is the prompt. And this over here, right? This is the function which returns promise. This is the prompt function itself, which I have explicitly annotated as async. And we know that it is async here. So it should... Like, this is the one that I want, right? I want to call the function. The function is known to be async. Oh, wait, no, it's not async. No. Here's the problem, right? The function is an expression, and the signature of the function is whether, like, figuring out what function to call is async or not, right? What we want to know is whether the function, which is the result of evaluating the f expression, is async or not, right? So I want to know that the type here. I want to know the type. So function type is f data signature type. Type await inferred, I guess. Type shape expect. So this must be a function. Right? So this is the type function, and this function, if this one is async, so this is the bool value. Yeah. So if this is async, then we're going to do that. Okay. Guess a number. Okay. Expected a function. When I'm transpiling the value shape from string, is that expected a function? Wait, are you saying that the f, the function that I'm calling, is not a function? What? What am I calling the call? When I'm instantiating the generic, or I'm doing this? Yeah. Well, I mean, I guess it's because it can be a generic. Right? So... Okay, let's do this. Let's match the inferred stuff, right? If this is a type function, then I will return a function async. If it is anything else, then I'm going to fail calling this question mark type shape and other. So what am I calling there? Yeah, I'm calling the generic. That's right. That makes sense because generics are just functions. So if this is a generic G, then what do we have on the G's? We have args and we have result. This is a type of the generic. I guess we just say false. This is never async. Okay, look at this. I am running the guessing number game. And it works. Amazing. Okay. Now the question, the real test here is going to be, if I compile my game, are we going to have a 1 billion FPSs? Also, I guess I can benchmark the test 2 here again. Right? So this is 270 milliseconds. Once again. Which is the proper performance, actually. For the lots of math, I guess, right? Let's also test the actual lots of math, right? This one takes 1 second still. So the difference is that the lots of math test this one is just using the standard library. But nothing here is supposed to be async, right? Let's take a look at the transpiler again. If I say that the async mode is going to be always, so that's what we had before, right? Then in this case, the performance is going to be even worse, right? Yeah. Wait, what was the performance? Is it 1 billion minutes to run this code if everything is async? Wait, was it that slow? $50? All right, so we have improved the performance 50 times then, right? By doing this. Okay, but my my test over here is, even although the code is the same, is different, is running faster. But why is this? It's because the we are not going through, like, I am doing the interpolation of the JavaScript code instead of going through. So because in the standard library, let's do this. Let's do benchmarking of the playground test 2 here, right? So this one is just 270 seconds. But if we do here Wait, am I sure? Do I need to do like no STD here, by the way? I thought I have to, right? I mean, it's the same. It just compiles faster, right? If I do this. Just like I have the conflict because the syntax is implemented twice. But the main issue here is that so what's called the most I guess is prime, which is equality, and the module operator, right? So what we can do here is we can say this, you know, rem rem A and B, right? So that's how it's implemented currently in standard library. We are delegating the A%B to the function rem, and then function rem is A and B, which returns the native cast op rem, which is then being called with A and B. Right? And if I do this, this is 20 more milliseconds. And then this also is generic. So this is type T here, type T, like that. And this returns like T. This does not increase the performance too much. Maybe if I... What else is there? Oh, maybe it is just a bunch of tries, right? Because is it the range? Like, because the loops have more unwindable blocks. Which means more try catches, which are not being used technically. Right? Like, what if I just say over here, you know, unwindable foo. But I don't like do anything there. Yeah, see, this is adding the overhead for sure. So just adding the try catch. So what, like, this may be a relatively simple optimization. Like, if I see for my unwindable block, if this value is not being used, then I can get rid of the unwindable block altogether. Right? All I need to do is to know if this is being used. But I cannot know that because the way loops are working is through the effect system, which is compile time. It's kind of annoying. So this is 1.4 seconds instead of 200 milliseconds, which means that it's slower, not by 50%, but 6 times slower. Let me commit this anyway. Let me also make sure that I am going to do everything in the standard library. Standard file system. Is file system async? I think it should be async. It is async in the JavaScript, I believe, right? The networking. Connecting is async. A read line is async. Write file is async. Close. I'm going to say that this is async too. Async. 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 Wait, now the question is... Hold on, the question is now... Let's do a test. Playground test. What if we write code like this, you know? What if we do this? What if we do this? For s in 0 to 10 dot 0 to 10 std iter map function, which is just doing the stdio input, like that, you know, do print s. Let's see here. This is a little bit annoying, but because this is a reversible iterator, it's okay. I can do this. There we go. See, now we have a bunch of promise pendings, and this is wrong. And this is wrong actually, because so we need to map, and this function is async here, right? So that's because the map over here. Let's see if this is going to work. So why is that? Why is it like that? Why is it not a compilation error actually? So we have the function, which we don't know if it's async or not, right? The function that I am applying there. Let's compile this and take a look. This has the standard library. It's annoying here to look at the output. So map itself this function Can I just say over here just input, and over here just do map, and over here just do print. Let's just say here use std inter map. That's going to be easier to see, right? Yeah, so so the body of the loop is not async. Right? And to look for a function which is like string into string, right? There we go. So this one is async. The argument is a function which is async. So because of that, the asynchronous of the iteration is still unknown. Right? But why is it unknown though? Oh wait, it says async is true, int32 into string. So yeah, this is the second. Wait, what? This is a tuple, which is map. Oh yes, because map has the first argument, which is the iterable, and we are mapping it like this. Yep. Okay. And the result is iterable string. What am I looking for? Can I say over here that const range is this thing? Does that help? Well, hold on. Let's like this is the function, right? This is the function over here. Iter is consume. And then we consume fa. So this f I don't understand what am I supposed to do here? Maybe dbg print type of map. So it should run without the JavaScript target. Hello? Let's run. Kast. What is happening? What is that? Why am I going into the REPL here? I'm supposed to go to the run, right? And then we eval and ignore. Which means that I never is supposed to go into the REPL. I'm never supposed to go into the REPL. Is my command line parsing is not correct? If I do guess a number, then it's fine. Oh wait, no, no. That makes sense actually. This is not the REPL. This is my my actual code. Because like the interpreter doesn't treat async as anything special. Right. I mean, what I can do, I guess, is test ks. I can do 0 to 0 here, so that I just see the output, right? So the map is the function that takes the function from A to B, which we don't know if it's async or not. Why not? Why did this not work? Hold on a second. Here's the other example then that I want to try. I want to say function f is a function that takes function g and then just calls function g, right? That's all, right? And then if I call function f using the input, using input like this, right? This is going to do that. So I want to dbg print type of f. Yes, so like over here, it is known that f is an async function that itself takes an async function as the argument. That's because that's what I did. But what if it is generic? Maybe it doesn't work because it's generic, right? Yeah. That makes sense. That does make sense. Can I do dbg print? Maybe I need to do this. Dbg print type of range map input this. That's what I want, right? So this is, for some reason, is the iterable of string, which we don't know if it is async or not. Why? Right? So if I say that map, let me make my own map. Map is the iterable and function f, and this is returning the object, where iterate is consumer iterable dot iterate item consumer f item, like something like this, right? Is what we want. So this one is not generic. Let's see what's going to happen. Right, so this now says that it is So wait, this says that it is async, but whether the argument is async is unknown. Whether the argument is async is unknown. Why not? Oh, whether a consumer is async is unknown, right? Yes, because this is the type of the iteration. So we know that the iteration itself is async because the f is async, but the consumer does not have to be async. Okay, yes, that's correct. That is correct. So how is this different from the other one? Right? Like, is it the code different there? The code is different because it's generic. And if it's, yeah, if I just make this generic and then I just lose everything. Why do I lose everything here? This is weird. Because like the t is not used in the definition of the function. I think the inference is kind of supposed to work the same way here. The inference is supposed to work the same way here. But what if I say this? This is async is equal to async. Function. No? If I say false here, then I'm going to have the compilation error. False is not true, of course, because we're calling this with async function. This over here is very weird. Like if I can like make this generic, if I don't use this t anywhere in the definition, then it should not matter, right? Because this is just instantiating the map with whatever, and it doesn't matter, but it loses the thing. Right? How about we do this? Map. How about this? We do const map is equal to map underscore. Right? How about this? And then I do dbg print type of map. So map itself is a function that takes the iterable and yes, over here, see async is true. Over here is also weird. Like, why is this underscore here? This should be an integer, right? Use std iterable. So this is going to be iterable int 32. And this should return iterable string, right? Okay, which one of these? If I make this underscore, this now shows an integer. If I don't type annotate this here, then it's underscore. Wait, what? That makes no sense. Right? Because this iter is the function that takes the integer as the argument, which means that this item is integer. I have something in the inference that doesn't work, it seems. And because I'm calling this function f using the item, it means that this function f takes integer as the argument, right? That's what that's how it's supposed to be inferred here, but it's not inferred for some reason, unless I am removing the generics, right? Because if I remove the generics, then it is inferred properly, and the asynchronous is inferred properly. This feels like maybe these are connected issues. So the problem is with the generics. Well, if I never call this function, then we don't know anything, right? It's supposed to be... Yeah, the reason we know that iterable is the range is because I was calling it over here, right? This is what drives the inference. So this works. And this doesn't. What if we just have underscore here? I don't really care about the arguments of the generics, right? Wait, what? Wait a second, why does this work? If I have t here, though... Wait, is that right? Wait, this makes even less sense. If this over here is t, then this is underscore. If this is underscore, then it is inferred to be an integer. And it is inferred to be async and stuff. Why is that? The underscore, well, it just means that we don't know the type, right? So like this generic argument, we don't even know anything about it. If we know the T, we also don't know anything about it, like, because it's not used inside. We don't even, yeah, we don't know, like, why is this? What? Excuse me? I remember that I had the problem with the inference completion, but something was not inferred. Maybe this is also connected to that bug. Seems like it is. How would I debug that, right? Like, what is supposed to happen here? I mean, this just makes absolutely no sense right now. So if I have this to be T, like T is not used inside, so it doesn't matter. Fine, let's make that this is like int32. Whatever. This doesn't matter. Like, it doesn't matter. It does not matter. Hold on. How about this? This is my function f, right? We're going to map using f, right? Let's say f is this function, right? So let's dbg print type of f also. So yeah, type of f is underscore into string. If I ever say that this is an integer, this is also inferred then, which makes sense. But it's supposed to be united because of this. Because of this. Is this like range map f? Let's do 0 to 1. Like, I'm like, it's actually being run, this code, right? Wait, it's not. Wait a second, what? This over here, let me comment that. Range map. Oh, I just need to do 4 underscore in this. Do nothing, right? Because we created the iterator, but I did not iterate over it. So this is like after printing, I'm printing it once. Yes, okay. So this is happening. Is the range... Range is always integers, yes. And that makes sense. How do I debug this? Boom, 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 boom. I don't need this. I guess I don't need that. And I don't need that. So I just print the type of map as inferred later. So the oh wait a second. Wait a second. Is the issue that, like, so when I'm instantiating the generics, I'm trying to replace all of the occurrences of the t in the type of this function to be equal to the actual t, right? But we don't see any occurrences of t here, and it's not going to be inferred like this. So instead, what we infer is like this thing in the beginning, right? Where map is the generic, where the t is not used on the result type. So we just have like underscores, nothing is inferred because we have not used this yet, right? But when I substitute, but the important part here should be that this underscore, like this not inferred thing, is equal to this not inferred thing, I guess. Which I can test if I do the printing of the types. If I do underscore, print variable inference var print let's do true here. So I'm going to see the ID here of the variable, right? This also prints all of the spans. I don't want the spans. You know what? Let's instead over here say the ID. So we are going to say unlike underscore ID print recursive. So like ID underscore. Right, so maybe this is the issue. Right, maybe I think this is the issue. Like this over here, 212.096. This is the argument of the function f. Right? And the argument of the function f is the thing that is expected in the iter. Right? So the iter function is the function that takes the consumer. So the consumer should take the 212.096, but it is not present here. So the inference is not correct. For some reason. Why is it not correct though? Like it is correct if I remove the generic, which is very weird. Can I make this example simpler? But so that it still doesn't work. Let's see. We have a generic g, which is a function. Let's do this. It is going to be the function apply. Apply is a function which has function and the argument, and it just calls the function with arguments, right? How about this? So then I do apply using the print function hello world, right? For example, something like this. Then I want to dbg print type of apply, right? So this is obviously going to be the string into unit. This is inferred properly. But what if I do the t here? What if I do the t and I say that apply is apply underscore? This works. What if I don't actually call this function? This is correct. So like this ID is the same as this ID. Is it because of the fields? How about this? Argument.value. And over here I'm calling this with value is equal to hello world. Oh, wait a second. No. This is like iterable is not nothing. Right. It's because I say iterable.iter and iterable.iter is the thing. Yeah. It actually does make sense here. A little bit. It does make sense here. Because I don't know what the type of iterable is. I only know when I call the function map with the range as the first argument. But that is called not on the... But like it does not enforce the type of the generic function. That enforces the one that is already instantiated. Which means that the inference here just stops. Until we know the type of this. Which is why, if I say that this is iterable underscore, I guess, then it's going to work. Yes. So if I say that this is underscore, then it doesn't work. Yes. Okay, that makes sense. That kind of makes sense. A little bit. So what am I trying to do then? What I'm trying to do is to make sure that this is async, right? So we want this code to work. But right now it works, but it doesn't work in the target.js, right? This returns the promise pending 10 times because it doesn't await this thing. Okay. So if I say that map is iterable f iter is iterable consumer iter item consumer f item. This works actually, right? So this works, but it doesn't work if it is generic. Is that right? Yes, that's right. because in this case the inference is done properly, and in this case the inference is not done properly. But if we do the type annotations here, right, so there's going to be iterable t, right? We have t and we have u, so we have a function which is t into u. This should return iterable u. Use std iterable. Okay, this is still pending. So what we want is we want to say over here that async is equal to async, and we want to be polymorphic over asynchronous like this, right? And in this case, does this help? Well, the asynchronous of this thing is supposed to be async is async. No? Wait, what? Skipping unexpected, right arrow at column 60. Wait, it's column 60. No, column 90. That's right. This one is unexpected. Why is this one unexpected though? What? I mean, let's get rid of it. This one is also unexpected. Wait, what? That makes no sense. I can have the function f, which is like async, that's into that, right? Like this works. And async is something. This also works, right? No, this doesn't work. Okay, it doesn't work if I do the equality for some reason. So if I have async equal value, this is weird because this is supposed to work. Do I have an issue in the parser too? Well, I mean, this is not supposed to be async actually. Now that I'm like thinking about it, right? The asynchronous should be on the iteration here, right? This iteration is async if the f is async, right? So this should be here. Async is async, but at the same time, like this is also not going to wait. This is parsing. Oh wait, I understand. It's because over here I have the round bracket, so it thinks that I'm calling this async here as this, right? So I need to like change the priorities there a little bit. It's okay. I guess I could do... It doesn't work with parentheses. Yeah, whatever. Kind of makes sense, though. So does this work? This doesn't work either, right? Because this is still the same. But why? Because when I'm doing the map, I'm instantiating this to something. But if I do this, const map is map. So async is going to be true, and the other things can be inferred. dbg print type of map. Yes, so we have this. Async is true here, actually. And async is true on the argument, which is correct. What if I do this underscore here? Is it going to be inferred properly? It's just not running properly for some reason? Yes, it is actually inferred properly to be async. Okay. Hold on. Well, I mean, it's supposed to be like ... underscore, I suppose. Wait, what? No? Yeah, I guess I need to like do this all 3 underscores. I don't know why though. Whatever. So this is inferred to be async. It's inferred to be async because of this is async, right? If I use instead print here, then it's going to be... well, this doesn't return the string, right? If I just return the string without inputting, then async is unknown, right? So the asynchronous is actually inferred based on this function, which is correct. So if it is inferred here, then why? Let's do this. So this is my like like iterator, right? Let's do iterator is this dbg print type of iterator. So the iterator is the one where the iter is async, right? So if I do type of iter.iter, right? This is just a function. No impl of type iterable as module. Wait, what? What do you mean? Oh, it's because like the priority is different. I need to do like in this iter.iter, right? And to fix the priorities there probably. Right, so this is a function which is async, takes string, returns unit. Right. So if it is async, then why does this not compile properly? Kast run. Let's take a look here. We have this loop block. This like loop body, right? and we'll await this iterator, and this iterator is like this thing. Wait, so yeah, this iterator is the one that has iter. And I am doing the await here, by the way. Wait a second. I'm doing the await. The iter is the object. Which calls function f. Wait, what does it call function f? I don't know why. Because it's a pipe. That makes sense. When we have the f inside of a pipe. Syntax sugar. Right, so this is just a range. And we have iter, which is this thing. But is this the... Yeah, this is the iterable and f, right? Why is this not... Yeah, this iter is supposed to be async over here. This iter is supposed to be async because we have the consumer here. So this is not inferred properly for some reason. Alright, you know what, guys? I'm going to go and eat and rest. This is still good progress, I guess. I will debug this later. Yeah, because it's interesting. It's inferred properly, but maybe not everywhere or something.
The only thing I've added to my take on AI is this.
Alright.
You can't be
Thank you guys for watching. See you next time. Bye.
And then use it to fuck up the art in another field, right? You can't complain about AI in programming and then use it to generate images, right? Because you're saying